Okay, let's get started. First off, my name is Austen Collins. I'm CEO founder of Serverless Inc. I created a pretty popular open source project called the Serverless Framework back in early 2015, right after AWS came out with AWS Lambda. I'm also an AWS community hero. And today I'm going to be chatting about outcomes, not infrastructure. This is kind of, well, Gunnar was so kind to ask us to present at Nordic Serverless about developer experience. And I think this is kind of one of the most important themes to consider when it comes to developer experience on serverless. And so I'm going to jump into this, but first off, I want to say thanks, Gunnar, for allowing me to present. This is my first presentation for the Nordic Serverless community, so it's super exciting. And great job, Chase. As a fellow West Coaster, I really appreciate you taking the morning shift, the early shift. It's helpful. So let's get started here. So before I get into the tools, just a little bit more about me. Serverless framework kind of came from a place where I guess I was trying to satisfy kind of the personal way I think about things, and specifically, I guess I just don't like to maintain things. I mean, that's kind of that's what motivated me to get started with serverless, and I think it's one of the truths behind the serverless community today. I think that there's a lot of great stuff being built today. There's tremendous innovation, and if you want to keep up, let alone lead, you can't do that if you're trying to build and maintain every single aspect of your software stack. So I think serverless has come in at the right time, and that's kind of what got me started in the early day when I saw AWS Lambda come out, and the promise that it held that you could build entire applications on top of AWS Lambda with really low total cost of ownership. I mean, we're talking next generation, extremely efficient serverless applications that are getting us closer to a set it and forget it type of architecture. We're not there yet, but serverless brings us pretty close. And that, those were kind of just early thoughts that got me started. But after that, what I realized while working on this is that AWS Lambda functions as a service on AWS, Google, other cloud providers. This isn't just a kind of a one-off service. To me, it was really the cloud evolving as a higher level of abstraction over the infrastructure. The cloud was always meant to be this abstraction over the infrastructure, and its first version was very infrastructure focused still. But this next version of the cloud, in my mind, is serverless, and by that I mean everything is auto-scaling. All these cloud services are auto-scaling. You never pay for idle, and they're increasingly focused on outcomes, business solutions out of the box, via APIs as a service for the most part. That is to say, you're not going to be asking Amazon in the future, for a virtual machine, as much as you're going to be asking Amazon. You're going to be showing it a picture and asking, hey Amazon, what's in this picture, or giving it a string of text and asking Amazon, hey, what's the emotional sentiment in this string of text, right? This new era of managed, aka serverless services on the cloud, feel very much like the cloud delivering on its promise to be a better abstraction over infrastructure for developers and for businesses who just want to focus on applications, on solving problems and building great products at the end of the day. And so that's kind of the themes and the way that we think about the serverless movement, serverless's kind of place in the history of IT, and the serverless framework in particular. The whole vision behind this project is that if the cloud is truly evolving to become these platforms that are filled with lots of serverless and managed services, and other clouds are evolving in the same direction. And there's also the smaller vendors out there like the Stripe, like the Twilios, like MailChimp. And if everything keeps evolving in this direction, there has got to be an application framework that can really corral all these services, help developers compose them into applications across vendors really easily and seamlessly, so that they could build applications faster than ever before, again, with very low operational cost. And so that's the vision behind the serverless framework. That's where, that's kind of where we got started and where we're going today. And it's I think it's an exciting time for serverless. It is the architecture, I think, that is extremely timely. I think that there's incredible pace of innovation out there. There's also some circumstances right now where companies are trying to figure out how to do more with less. And I think serverless is a perfect solution for that generally. So that's a bit about the company, a bit about the framework. And as of today, there's a tremendous community behind this project. It is open source. This is a little bit outdated. We're probably, I think we just crossed our 36,000 GitHub star mark, which is phenomenal. Again, we really didn't know that this was going to be such a big deal when we first got started. But tons of Global 2000s, Fortune 500s are using the framework. They consider it an engineering standard within their organization. And yeah, this thing is got a life of its own now. So let's chat about developer experience. And this is a topic that is near and dear to my heart. I think about this every day and have thought about it every day for many years. In this era of managed services and serverless services, to me, these are like the greatest building blocks of all time for developers. I mean, really, you don't have to write custom code and build all these things yourself anymore. You could just take them off the shelf, stitch them together to make more than ever before. And if we're going to realize that vision, I think that there's got to be some great application experience around that at the end of the day. It's up to the tools to make that accessible, because again, there's a lot of challenges there. I'm going to be totally straightforward with kind of what those are, because if we're going to talk about serverless developer experience, we have to be upfront about the challenges. And the biggest one in my mind is this. This is the problem that I've been trying to solve, that our whole team has been trying to solve since day one. And that is, serverless is great, serviceful is hard. Serverless, everybody wants it. Auto scaling, never pay for idle, kind of outcomes as a service, managed services, APIs as a service for everything. That's fantastic. But serviceful, when you actually take all these things and stitch them together into an application, that's very difficult. There's a lot of challenges that come with that. And this is what a typical serverless architecture will look like at the end of the day. And this is an example of the many services that are involved in kind of the configuration and composition challenges that you'll face with this. And this is mostly a traditional REST API kind of serverless backend. This is very common. And what we found since day one is that kind of more services, more problems generally. Again, these are, some people call them serviceful, some people call these distributed systems. And these aren't unusual. I just think the difference in serverless is that there are a lot of them now, right? It's great because they empower developers. They help you deliver software faster than ever. But again, you have to figure out how to compose these together. And there was a recent tweet that kind of put the serverless community up in arms recently that I think is worth calling out here, because it just touches on this theme kind of perfectly. And that is, hey, look, these are really this powerful technology here and powerful services, but to kind of put all this stuff together and compose it together at the infrastructure level it just seems like there's a lot of new complexity that is introduced with that. So in addition to that, when you have all these services and you're developing across them, that can be quite slow and tedious. Actually, there's a lot of different changes that come into play when you're trying to work on services that only exist in the cloud and they're not really running locally on your machine. To actually work on those, what most teams are doing is they end up trying to emulate those cloud services locally, or they try and deploy their changes. And kind of up until this point, deploying changes to the cloud has just taken a long time. And so you end up with this pretty slow development cycle here. And the problem with that is that development is all about flow for developers. They've got to, when they're working and they're focused on delivering something, they try and stay in a flow and get distracted the least amount possible. And every time you have to do a deployment or deal with some local emulation issue, that breaks flow and it slows them down. Additionally, when you have a lot of services and a serviceful architecture, there are a lot of differences in the whole application lifecycle, not just development, but we're talking testing, deployment, monitoring, security. You really have to go about that in a few different ways. And that introduces some complexity when you're trying to bring these applications into production. And it's something worth recognizing up front. And lastly, when you have all these new services, there's a big difference in the solo developer who's just working on this stuff in isolation. Usually things are much easier at that point. But then as those projects grow in complexity, there's more services, or you add more team members onto that project, there are a lot of new challenges that come into play as well. And we really have to think about that because, again, it's very easy to design solutions for a single developer, but as you expand that across multiple teammates, within an enterprise context, within a large company context, things get more challenging. So I think, after all this time, I've been personally focused on these problems since 2015. And I've watched as the serverless community, the serverless movement has evolved and turn into something that is, both wonderful, but still has a lot of these challenges at the end of the day. I think the single solution, the single most important thing that we need to do as a serverless community, as a tooling provider, as an infrastructure, as a service company, is that we have to give users opinions. This is the time where they really need help trying to figure out how to compose all those things together. And fortunately for us, we are an opinion company. That's how we got started. So we got started with Serverless Framework, this open source project here. And what this open source project did, I think, that is the main reason behind its success, is that it came out with a simple opinion that looks like this. This is a very commonplace serverless application. And the use case here is a serverless REST API. Now, to deploy a serverless REST API, there's a lot of services involved. You're dealing with AWS API Gateway, which is AWS's managed API Gateway service. You're dealing with AWS Lambda, which handles the compute, the business logic. You may have to deal with, you most likely will have to deal with IAM rules, permissions for what your API Gateway can do, what your Lambda function can do, and then, of course, databases, anything else that's a infrastructure dependency to actually perform your business logic. There's a lot there. And to approach, it makes it hard to approach as a developer. But I think the thing that perhaps we got right in the early days was we came out with this opinion, which was a simple story of functions and events. And so all you have to do to describe your serverless application is to list out a function in YAML here, point to the business logic, and then list out the events that will actually trigger that logic to run. And with this minimal syntax, the serverless framework is going to go and it's going to go deploy a whole bunch of cloud infrastructure for you. It's going to deploy AWS API Gateway, it's going to deploy an AWS Lambda function, necessary IAM roles, and then also upload your code on top of that. And as a developer, you don't really have to think about the infrastructure complexity, the managed service complexity in the background. All you have to think about is really, I've got some logic and I want to run it in response to an HTTP request on a /submit path via a post method. And this is all you need to get a serverless REST API up and running. And this got us pretty far. I think, for a while, this really simplified serverless applications as a concept. As aside from just serverless compute in isolation, this gave people a model to think about how to design an entire application. And I think what happened next, which has been, again, wonderful, but also different, is that the cloud providers have come out with so many new serverless services. They've come out with, they've refactored old services like DynamoDB to be increasingly serverless, and they've come out with a whole bunch of other serverless services like EventBridge, new version of API Gateway, step functions, a managed GraphQL gateway product called AppSync. And there are a lot of great use cases and a lot of great potential that comes out of this. But we need to figure out how to scale better on the tooling side to actually accommodate all these new use cases, all this wonderful possibility for developers, so that they could use all these different services and create lots of different types of serverless applications. And so what we've been focused on lately is just trying to figure out a better way to model out those applications and model out this growing number of serverless use cases that developers can do. And that's what I'm going to show off today. And I'm going to kick it off with just a single deploy. I think that a REST API backends and web applications are one of the most popular serverless use cases out there. So I'm going to start off with using some of our new serverless framework technologies to deploy that. And so within a few seconds here, I'm going to deploy a few things. There is an API. This is a typical REST API running on AWS Lambda. There is a database, DynamoDB table, that is that the business logic is interacting with on the API side. There's an IAM role for locking down permissions for the API. And then there's also a front end, a whole static website. So this is full stack application out of the box, which I've just deployed in about 24 seconds here. And I'm going to load it so we can take a look. And this is live right now. Anyone watching this can interact with it. It's at serverless-fullstack-app-dev. And here's the full stack application I just deployed. Pretty simple, kind of run-of-the-mill application at the end of the day, not very sophisticated, but it shows off the fundamentals of a web application. We've got basically users, CRUD, private and public API routes, as well as front end, and some basic persistence, as well as some permissions to lock down what the backend code can interact with. And this is it. Within about 22 seconds, we have a full serverless application. And let's dig into this just a little bit further. So first off, the API side is using one of our new technologies called components. And this kind of brings me into getting into solutions to some of the problems that I covered earlier. And that is, yes, there are a bunch of services in a serverless architecture, and that does introduce some complexity into your project. And however, I think the more we could design higher order abstractions, focus more on use cases, and move slightly away from the infrastructure level, the more simplicity we can create for developers at the end of the day. So that's what we're doing here. The components concept is simply declare the component that you're using. And there are serverless framework components now for a ton of popular use cases, backends, front ends, GraphQL APIs, all types of stuff. And these are designed to be at a higher level of abstraction. So this component in particular takes Express.js applications, typical Express run-of-the-mill web framework applications, and it will actually take your Express application and package it onto serverless infrastructure. And it does all of that automatically with a great new fast deployment technology that we've also built. So this right here is the API. Here you can see the traditional Express.js application. And over here on serverless.yaml, we have a few inputs to define the configuration for this application. Now, one big lesson for me that I've learned along this journey is that it is very easy to design a developer tool or a developer experience once you know what the use case is, as opposed to something that is trying to accommodate every possible use case. This is why this configuration is focused and relevant to only deploying an Express REST API, as opposed to a traditional CloudFormation or a Terraform configuration, which is focused only on the infrastructure level and trying to accommodate every possible piece of infrastructure configuration option and ways you can compose it. But no, this is much simpler. This is focused on this component, and all components are designed to do specific things. So if you wanted to deploy a simple Express REST API on serverless compute, this is all it takes. So I'll go ahead and do just one other deployment here. I'm going to CD into the Express component and run serverless deploy. And again, we're just going to push a non kind of monumental update to the Express application. But this is it. This is out of the box Express running, and now what this is running on at the end of the day is AWS Lambda as well as AWS HTTP API. So this is using Lambda, auto scaling pay per execution compute on AWS, as well as AWS's new API gateway product, which is HTTP API. And getting back to the theme of this talk, outcomes and opinions. What components are simple opinions on how to put together a use case best on serverless applications, and then those are wrapped in a great developer experience. So again, this takes Express packages on AWS Lambda, AWS HTTP API, and you're getting the best way to deploy a monolithic application onto serverless infrastructure, and that scales to serve millions of users, as well as pretty cost efficient. So looking at the cost of this API, I've got some rough notes on this. Based on this memory size, about 512 megabytes for the Lambda application. This cost per request. Again, this whole use case doesn't charge you anything unless it runs. Costs about 0.000008 cents per request. At about 1 million requests with HTTP API factored in and AWS Lambda, this is going to cost you $1.80. Otherwise, when it's not running this whole API, it's not going to cost you anything. And so, kind of getting back to everyone loves serverless, like this is the reason why. You could deliver applications like this with extremely low total cost of ownership, very efficient, that only charge you whenever they run. There's also DynamoDB on demand here. So digging into the components model a little bit further, there is a DynamoDB component, which you could easily use with the serverless framework to deploy a DynamoDB table. And again, every single component here has simple inputs and outputs. There is basically any configuration option you would like to do with DynamoDB is exposed here as an input. And when every single component is deployed, I run serverless info, you will see that it's exporting outputs here. So this is important to solve the problem of composition. It's like, great, we've got these higher order abstractions that we can use to deploy outcomes on serverless infrastructure faster than ever. But now how do we start to compose these to put together an entire application? And this is the answer to that. So DynamoDB is exporting a few outputs, and those can be inherited by other components here. So you can see in my environment variables of my Express API, I am referencing the DynamoDB table name as an environment variable so that my backend logic can actually interact with the DynamoDB database. Furthermore, there's also an AWS IAM role component. If you want to deploy an AWS IAM role really easily, again, define your policy in here via the simple inputs model, and then it's going to export outputs, which are also being inherited by the backend API. So here you can see I'm passing in a custom role to give my single AWS Lambda function permission to interact with DynamoDB as well as CloudWatch logs. And now you can see some basic composition here. And I think what's really interesting is, going back to the managed service diagram that I showed off before, which was very low-level infrastructure specific. What we have here is a mix, it's a blend of higher level pieces where there's just an opinion to deliver a serverless outcome on serverless infrastructure where you don't have to think about that as much, but it's also leveraging lower level pieces too. Full stack, AWS IAM in particular, and AWS DynamoDB. And I think this is one of the big things that the serverless community and serverless tools need to focus on today. And that is, how do we move from all this low-level infrastructure composition up into a blend of higher order abstractions and other low-level pieces? And this is exactly what that delivers via a simple inputs and outputs model. And again, the end result here is pretty darn efficient. Lastly, the serverless website. So I showed off Serverless Express, and on the website, we're actually using React. So this simple website component will deploy AWS S3 bucket, AWS CloudFront distribution to leverage as a CDN. And you can put any type of web framework on top of that. And what you get is a simple way to deploy websites on serverless cloud infrastructure that are really dirt cheap and massively scalable. And these are all the pieces in that full stack application. So higher order abstractions, outcomes, focused on use cases, not just infrastructure. I think that's one of the, this is the direction that we're increasingly heading. And I think it's the direction that the serverless community in general needs to consider at this time. In the early days, there weren't as many serverless services. So managing everything at the infrastructure level seemed a bit more reasonable. But now there's a lot more services. And it's fantastic, again, because of the power that it gives to developers and companies. But there's a lot more to think about there. And so the better we could blend higher order serverless abstractions with lower level pieces, I think the easier and more approachable serverless becomes. Up next is another area of focus for us on our kind of next generation of tools. So I showed off these higher order abstractions, and there's some important design principles behind these. In particular, this is not a kind of a generic REST API component in this specific example. Instead, one thing we've learned is that when developers are trying to adopt serverless and they have to look at all the managed services and figure out how to design applications on top of them, they get nervous that they have to re-architect everything. And that's what a lot of people have been trying to do up until this point. And unfortunately, if you ask developers or organizations to contemplate a re-architecture, it's a big ask, and you can expect to lose a lot of interest right there up front. So, and then also there's just a lot of learning to do. There's a lot more time between when a developer gets started and when they can achieve an outcome. So a big thing that we're focused on right now is not trying to rethink how you build applications for the most part when it comes to adopting serverless cloud infrastructure. Instead, we're trying to give developers experiences that are super familiar, hence the Express component. You do not have to think about, even though this is running on AWS Lambda, it's using AWS HTTP API as an API gateway product. You do not have to think about re-architecting to leverage those individual pieces. Instead, you could take your existing Express application and port it right onto this. And to take it one step further, where we'd like to go with this is it's not just about the higher order abstractions or designing those around the experiences that developers kind of know and love today, but further, the whole development process is also something that we're trying to improve. So traditionally, with serverless and leveraging something like CloudFormation, to perform a deployment could take around 2 minutes, could take 5 minutes, depending on the level of changes that are involved there. And again, the implication this has for the developer experience is that most people look at that and they think this is really slow. Let's go and try and leverage local emulation and some type of offline experience, which the serverless framework has. So we've focused on that for since the beginning, really emulating AWS Lambda, AWS API Gateway, as well as lots of other cloud services. However, as projects scale in complexity and teams, maintaining that local emulation, in our experience, has always been pretty difficult. It's easy, again, when there's one developer and the project's small, but as other people are trying to inherit that and figure out how to run the local emulation, they end up almost kind of creating so much new maintenance work that you're kind of reducing the opportunity cost that serverless gives you in the first place. So one thing we focused on a lot with this is reducing deployment speed. We think if we could just reduce deployment speed and allow developers to push all changes to the live serverless services on the cloud, this will solve a ton of problems. We also think that serverless development is best done on the cloud because, aside from the local emulation scaling and collaboration issues, in addition to that, it's never a perfect emulation, right? And when you push those changes into your production environment on the cloud, there's a high likelihood that you'll run into some API limit, some permission issue, or something else that you just didn't catch in the local environment. So we think in many ways that's not a great place to do a lot of development. And it's hard to get a sense of performance, how the whole system is performing, all of that. So again, we want to reduce deployment speed down to about 3 seconds is our goal. We want to make that as fast as doing a hot module reload when you're working with a front-end React app. So that is something we put in a lot of work into. And despite the video streaming, the screen sharing, and the webcam sharing on this connection, still I'm achieving about 6-second deployments here, which is pretty great. So first, give developers an experience they're familiar with. Second, reduce deployment speed so that they could push changes rapidly to the cloud and work on the cloud. And then up next is kind of the final piece of all of this. And this is our new serverless dev mode, which is available for all components that involve writing code. So if you run serverless dev, what's going to happen here is we're going to set up a watcher. So if you're actually working in your application and you push changes, for example, I will I'll push a hello world console log statement. The developer can hit save and immediately uses the fast deployment technology to push the change to the real cloud environment, and it's up and running. Second, this CLI session is actually streaming logs in real time from the live Lambda directly into the console here. And so if I go over to this and I refresh, this web application here is performing a request to fetch the user record from the backend API. So it performs that request right here on every single load. There it is. And you can see log statements streaming in real time from this. And I'm actually hitting the wrong endpoint, so let me try and hit the correct one to actually show the log statement. And there it is. So I've hit this test endpoint, and it's just rendering a generic request receive page. But you can see the logs are streaming in as fast as possible in real time. And the benefit here is, again, going back to the development flow of serverless, when you have to re-architect and kind of figure out how to remodel your applications, that's a barrier to entry. Being able to use the stuff that you know and love already and are familiar with is much easier. So hence the component use case focused experience. Further, fast deployments allow developers to push changes to the cloud near instantly. And then third, to speed up the feedback cycle. When you're working, you don't want to have to wait 2 to 3 minutes to 5 minutes to actually see the effect of a code change or any change. We stream logs back into the console in real time. So this streams logs. This also streams errors, for example. So I'll just put in some type of undefined variable. I'll hit save. This pushes it to my environment here. And I'll go ahead and refresh. And this renders a internal serverless error. And here's the error in my console in real time, right? And I can see the stack trace here. And for those who haven't experienced kind of the slowness of doing this with other tooling and CloudFormation-based deployments, the feedback to do the deployment and then fetch the logs, that whole cycle is not just about slow deployment speed, but also CloudWatch itself can take up to 30 seconds just to return the logs. So there's just a lot of slowness in being able to tell, is this thing working at the end of the day? All that is gone now. So again, familiar experience, super fast deployments, slick watching experience, and then streaming log statements and errors into the console in real time. You'll see us pretty ambitiously ship a lot of other serverless components to the market over the coming months. What we have today can be found over here in the serverless components organization. I'm getting the spinning beach ball of death, so hopefully my my video connection is still working. Gunnar, if you could just let me know if everything is streaming okay in the chat, that'd be helpful. So here are serverless components. Here's the org. Here's where you can find them. Over here, you'll see we've got the website component, the Express component. There's a great new one for just deploying GraphQL on AWS AppSync, and then as well as lower level components, and I think about 30 or 40 more at this point. And again, the goals: simple experience, design around that's familiar, design around the use cases that developers know and love already, with a really fast feedback cycle and development cycle. The other part of this is, though these things are simple, though these components look simple and are easy to use, that does not mean that they are not powerful. And so there are a lot of advanced use cases that are actually built into these components. A good example of this are Canary deployments. At scale, if you have a potentially risky code change, you may want to only put that code change into production and serve about 20% or a small fraction of your traffic with it to ensure that it's not erroring out. It doesn't have any other performance related issues. So if I go in here into the Express component, this actually has Canary deployments built in. Whereas otherwise, teams typically have to go figure this stuff out themselves. They have to figure out at the infrastructure level how to actually perform a Canary deployment and do that well. But again, this is built in here. So I have my test endpoint. I'm going to clean it out. And again, it just renders request receive. I'll do a quick deployment here to show the stable code. And let's go ahead and try pushing a change into the cloud. And I'm going to change the response to be experimental code. And I'll save this, run another manual deployment. And again, what I've done here is I've put in a traffic property that says only serve 50% of the traffic with this new deployment. So I'm going to run serverless deploy with this new change. And this is going to push that to the cloud. And let's go back over to the test endpoint. And this should render request received, request received. And there it is. You can see it changing back and forth between experimental code and request received. So I'm effectively serving 50% of my traffic with the stable code and the other half of the traffic to the experimental code. And of course, when I'm ready to push that change completely into production, I'll just remove the traffic property and deploy it. So easy, approachable, simple serverless use cases, but also advanced when you need them. This is a very limited kind of preview of the configuration that's available. There's a ton of stuff that you can do with every single component. And the beauty, again, one of the big lessons I've learned, when it comes to developer experience is, once you know what the use case is, you can actually provide a better developer experience. Whereas if you're focused on every use case, it becomes much harder. So there's a lot of configuration options to instantly do things the best way, in an opinionated way, that teams used to have to figure out themselves. They used to have to figure out, again, how to do a Canary deployment across a custom infrastructure pattern. And in our experience, after working with hundreds, if not thousands, of serverless teams, they're going to get that wrong 99% of the time on first go, right? But if we give them great opinions, great experiences, where all the unnecessary details are hidden away, abstracted away, and only the stuff that matters for the use case, we could offer a developer experience that is much easier and much more accessible to everybody who wants to leverage serverless. And there's one other piece I want to show off. I did talk a bit about scaling teams and scaling projects. And I showed off the outputs and inputs convention around components. But there's another part of this. Serverless Framework has built-in a staging concept. So that you could actually add different, you could create separate instances of every single component. And the beauty of this is, by leveraging the stage flag, I'll quickly push changes up into the production instance of this. But one thing we've noticed, well, when it comes to collaboration and teams working on serverless applications at scale, is that when you have a lot of services in your cloud architecture, it's really hard to have everybody work across all those in an easy way without stepping on other toes or getting blocked by somebody else. And it's a common problem with all application architectures. I think serverless there's some key differences that are introduced there. And so what we've done here with the fast deployments technology and helping everyone work in the cloud, we've made it so easy to go push changes, spin up another instance in another stage. So it could be on another AWS account, could be in the same AWS account. And with our simple outputs convention, we've done something that that helps out the collaboration flow a lot. And that is, you don't need to just reference, you're not limited to just referencing outputs coming from components in other stages. Instead, you could actually reference outputs from components across stages. And this is a pretty killer feature in this classic scenario. There's a shared dev environment. There are developers working on that shared dev environment, and someone wants to go push changes to this REST API. So what they could do here is they could either use the CLI flag or just hard code a custom stage while they're working. But they could only spin up this piece into a separate environment or as a separate instance, yet they could still reference resources from the common development environment. And the reason why this is such a big deal is because before this, developers would have to spin up the entire development environment themselves, which is very tedious, again, depending on the scale and complexity of your application, to spin up the entire dev environment just to push some changes to an API. With this, you could push up pieces really, really fast, have this great developer experience. You can iterate quickly while referencing the pieces from a different stage. I could even switch this, for example, to do API changes and reference the production database at the end of the day, which is very powerful. I think we've thought a lot about how to do team collaboration in serverless architectures, in the cloud, in the real world context. And this feature alone is what we think is a game changer for these serverless teams. So I think that is the gist of what we're focused on today, and kind of how we think about serverless architecture, how we want to move forward with developer tooling on more of an outcome basis, a use case basis. And I think this is, again, necessary more than ever. It's a great time right now. The cloud is turning more serverless. It's highly likely the cloud will be completely serverless one day. And the cloud providers are shipping a ton of great high quality managed serverless services for all types of use cases, doing all types of things. It's really kind of a new golden era for software development. But there's got to be a single tool, something that could help wrangle these in and provide a great application experience around that makes it accessible to developers, makes it easy to scale across teams. And that is our goal. And I think as of right now, with all the new options, the new services, opinions are needed more than ever. So that is exactly what these are. Again, we're sort of in the opinion business. Serverless Framework version 1 was an opinion. Components are just more opinions on how to do these things. So if you have feedback, if you want to get started trying this stuff out today, this stuff is free to use. You can go to serverless.com or just check out the Serverless Components repository. Here you'll find a whole bunch of components that you could deploy within seconds. Hands down, the best thing to use to learn all this is the full stack application example that I just showed off. So everything I showed off here is in GitHub. It is a great starting point for building a full stack application on Express.js, on React, on DynamoDB. There's a lot of great opinions in here. There's authentication, authorization built into this as well. And again, the economics of this project are just incredible. Only over $1 for 1 million users at scale, and you don't have to pay anything at idle, and it'll scale to serve millions and millions of users. It doesn't get any better than that. So if you want to engage with this stuff, check out the full stack app, check out full stack components. Otherwise, we also have a handful of other products. We have monitoring, troubleshooting, CI/CD built into the framework. I didn't cover all that stuff today, but you can check it out at serverless.com. So that said, I will go ahead and answer some questions if there are any, and hand it off to you, Gunnar.
All right, thank you very much, Austen. That was a great talk, and we actually do have some questions. Fellow AWS Hero Anton Babenko has a question. If you've considered to extending serverless framework by allowing developers to use Terraform modules as native components.
Yes, so Chase spoke about this a bit, and it's an important point for the serverless community. That is that serverless, depending on the size of the company, the company might be purely focused on serverless, or if it's a larger company, it's likely that they have a mesh of technologies that they've used, a lot of legacy stuff, and they're probably playing with a few other new things. So we always have to think about how serverless is great for these teams that are pure serverless and they're trying to build everything in a serverless first fashion, but also how we integrate within the context of a company's existing investments and technologies. And Terraform is pretty common. And we've got some great expertise here. The PM of our Serverless Framework Pro product was actually the previous PM of Terraform Enterprise. So we have a handful of integrations coming with Terraform in particular, and especially around components. Components is the first time where we had a great architectural foundation to build abstractions over anything at the end of the day. So you will see us ship shortly here a ton of Terraform integrations, some integrations with CloudFormation in the form of components, integrations with all other types of technologies, which you could use via the simple inputs and outputs composition principle. So that is coming shortly. Otherwise, there's also a lot of ways you can interact with Terraform today with the Serverless Framework. There's been a ton of great blog posts and thought leadership done in this already. Some of that's on our blog. Some of that is just search for Serverless Framework in Terraform.
All right. And looking at components, do you see it as a challenge to get developers that are used to configuring everything, they're writing their long serverless YAML files to start using something that is more opinionated like components?
That's a great question. First off, what really motivates us is that when we look at our numbers and the traction and the fortunate growth we have with the serverless framework, it's pretty clear that there are going to be more serverless developers within like 1 to 2 years than we've accrued over the past 4 to 5 years. And it's great. I mean, serverless is truly growing. The adoption is growing. And what we're trying to think about today is, of course, how we support a lot of the previous ways that we thought about serverless, but also how we make it accessible to all these new developers, new to serverless developers and teams and companies that are coming on board. And again, some of the biggest friction points are, people come to serverless and they do get intimidated by those infrastructure diagrams, right? And the request to re-architect and kind of rethink and not be able to use your traditional tools, frameworks, and development experience. That is a big barrier to entry. So the way we think about it is, I think people who are used to CloudFormation and really want to go super low level, that experience is available. That's in Serverless Framework version 1. Additionally, we have a CloudFormation component coming out so that you could just describe a single CloudFormation template in a component and leverage our inputs and outputs feature to compose really low level CloudFormation with these high level outcomes and abstractions. And with that, I think that there's a lot of flexibility for whatever teams want to use. Everything is optional, of course. Components is not meant to override V1, supersede V1. It's meant to complement it. Where we had this single great opinion. Now we're coming out with more for the most common serverless use cases. So, and again, it's everyone has different. It's always a balancing act between control and abstraction, right? And if you're going to build a great developer tool, you are juggling that every single day, right? Trying to find the right amount. And the truth is that there's a bunch of different types of people out there. It takes all kind to make a world, and they are operating under a lot of different company policies, regulatory requirements, and they have different needs at the end of the day. So the right amount of flexibility, being able to mix and match this low-level stuff with the higher order stuff is key to success, we think. So nobody should be stuck with one thing or the other.
All right. And you talked about 3-second deployments. You were at 6, I think, now. So yeah. What's left? How do you reach those 3 seconds? I think you pushed it quite far already, right?
Yeah. So thanks for asking about that, because yeah, I'm showing it off in a brief demo where, it's like, it's just kind of a quick thing and it seems pretty trivial, but behind the scenes, our team has been geeking out for years on how to make this happen, and make this happen for everything. Again, our goal, serverless framework, we really want this to be the application framework for the serverless and managed service era. And to actually do fast deployments across different providers, not just AWS and a lot more, is quite a challenge. And to do that in a uniform way where you could build all these other abstractions on top of it. So what's left? How do we get this even faster? Because again, I think what we're chasing here is what I said earlier, is that hot module reloading experience where, with React, you do a code change and then you go look at it and it's just there. We want to get there for serverless. We need to get there. So what's left? 2 things. We do have a big upgrade coming to this within about a month. The biggest slowness right now is just uploading, right? So depending on the size of your application, depending on your internet connection, it could take a little while to just upload the code at the end of the day. So that is something we're fixing with some caching, some really clever caching stuff that we're doing, where it's only uploading certain pieces that have been changed, whereas everything that hasn't been changed is not going to be uploaded. That's going to cut this down to closer to 3 seconds, if not shorter than that, because this is probably, I could actually run a serverless deploy debug command right here. And this is going to show all the stuff that the component is doing in the background. If you really want to get a better understanding of, in my demo, I was messing up the project file. So if you want to get a better understanding of all the things that are being created behind the scenes, run deploy with a debug flag. And if you look at this, it's not listing anything because this is all uploading, and I have a slow internet connection. I'm doing this chat, and then everything else. You saw the data dump of all the log statements of all the API requests happening across AWS. That stuff happened. We've been able to speed this stuff up so much that this all happened. All these API requests, all these SDK calls happen within about a second, and so about 6 seconds, I'd say, was just uploading. So as soon as we get the smart caching in place, that's going to be the next big killer improvement. And then one other part of this that's really interesting. Again, I talked about this a lot earlier, but really in my experience, if you want to build a great tool, you have to know what the goal is of the tool, right? And again, if you're building developer tools, if you know what that use case is, if you know what the user is trying to achieve, you are in an enlightened position to offer advanced automation, stuff that CloudFormation, typical infrastructure provisioning technologies can't do. You can start thinking about application automation. Like, what other types of automation can I package with this use case? Why shouldn't this Express component know how to test itself? Why shouldn't there be an SDK command so it could auto-generate SDKs across languages for me? Why shouldn't it know how to document itself? So this is where we are moving next, and it's kind of pushing the limit on kind of what we think of as infrastructure provisioning to get more into just generic application automation that ships with these use case focused components so developers don't have to worry about all that stuff. And with that knowledge of what the goal is that needs to be deployed, you actually know how to make the fastest deployment pattern at the end of the day. Because again, you're not trying to build a system that's trying to deploy any infrastructure combination. We did not go and recreate Terraform or CloudFormation. Instead, each one of these is a script that knows how to deploy its outcome. And again, once you know what that outcome is, you could deploy the infrastructure more quickly and more safely, because you also know what the pitfalls are when you're deploying something. Like this AWS IAM role is not available yet. So with that knowledge, again, that is a big advantage when designing a developer tool and a great developer experience. you'll see us do some really innovative automation that ships with this in the future. That's pretty groundbreaking. I haven't seen anything that is taking an approach like this before. But in addition to that, every single component is being written and rewritten to be faster and faster in how it provisions all that stuff. So these API requests, like we should get these down from 1 second to 500 milliseconds soon in the near future. So we're close. It's really the upload speed, I think, is the big one right now, which we should have solved in about a month.
All right, that's interesting. Looking forward to it. All right, Austen. With that, thank you very much once again. Great talk and great to hear from you about using serverless framework and the developer experience. Anything last you want to add? Platform, perhaps you mentioned it just briefly.
Yeah, sure, absolutely. I do want to share something. When I started the presentation, all my slides were immediately out of order. I don't know what happened there, but everything got mixed up immediately. So I totally mostly had to wing this talk, and I hope it was valuable for everybody who was watching. But it was like, Gunnar, maybe you'll appreciate this. It was like a chaos monkey or something in my slide deck, moving stuff around. It's chaos presentations.
You found the shuffle button.
Yeah, so you know, that's it. You can find us largely at serverless.com. Again, what you'll see us continue to work on as well is the later stage application features that we've been working on for a long while. With Serverless Framework now, when you deploy, you will get metrics out of the box. You could have CI/CD set up within a quick second, and alerts set up, notifications set up. Our goal is when you deploy with Serverless Framework, you should be able to reach deployment as fast as ever based on an experience that you're familiar with, and be able to go into production upon first deployment. So that's kind of our rallying cry right now. You should not have to instrument anything. You should not have to configure anything. We want to bake in the best defaults possible. Again, a more of a use case focused helps us achieve that better than ever. And so once you deploy, you have all of this API requests out of the box. If you're deploying an API, you want to know the actual volume of requests, not just function invocations, because that'll miss out on a lot of important data. And more importantly, advanced deep dive functionality. So everything I'm showing off, you get the ability to do a deep dive on every single transaction, query across API requests, query across function invocations, a bunch across custom tags, status codes, all that. Look into each individual transaction, get a simple distributed trace of what's going on in your function. Anything in the function code is automatically instrumented. So again, one of our rallying cries, you shouldn't have to instrument anything. So we will show DynamoDB requests, any AWS managed service request automatically is visualized here. And all this is available to everybody with Serverless Framework. All you have to do is deploy with Serverless Framework and log in. There are a lot of other great features coming. We've got a Postman experience built into the dashboard that we're rolling out in beta, if you want to try that. The beauty there is if you use Postman or any REST client, you have to go enter in all your API endpoints into those REST clients, and that takes quite a while, and it's not fun to maintain, especially across teams. So, but we're the application framework. We know what you're trying to define. We know the application endpoints, all of that. And so that just shows up, and it's always updated in the REST client that we have. Again, also CI/CD built in out of the box, and a bunch of team collaboration features, which is super important. There's ways to define secrets in here, everything you need. And again, all you have to do is just use Serverless Framework and deploy. And our goal is to give you everything you need out of the box upon that first deployment, wrapped in a really great experience. So check it out, serverless.com. That's where you can find us. Otherwise, I don't have anything else to add, Gunnar. Really appreciate the time to chat with the Nordic Serverless community. Maybe, hopefully, in the near future, I can come out there and do something in real life.
Yes, let's do it in person next time. Definitely.
Yeah. So thank you.
Okay. Thank you very much, Austen.